Hi guys, today we're going to have a look at some more laws for logs. This time looking at some rules we know for indices and thinking about what that means in terms of logs. So if we had a to the 5 times a to the 7, you would know that that would be a to the 5 plus 7. Well, we know that a log sort of undoes a power. So a log follows a rule similar to this, but not exactly the same. So it's sort of a reverse of the log rule. So what the reverse log rule gives you is that the log to the base a of 5 times 7 is equal to log to the base a of 5 plus log to the base a of 7. So I think you can see quite clearly that it is connected to that, but like a log being an undone way of doing something. So say I said that we wanted to do, so an example question could be, what is log to the base 6 of 4 plus log to the base 6 of 9. Now, using our law of logs, log to the base 6 of 4 plus log to the base 6 of 9 is the same as saying log to the base 6 of 36. So this is then saying what power of 6 is 36, and the answer is 2. So let's just double check that on our calculator. So first of all, log to the base 6 of 36 is equal to 2. But let's also look at log to the base 6 of 4 times log to the base 6 of 9. Sorry, don't know what I was doing there. Again, 2. I had myself worried. Right, so that's the first one that we want to think about. Let's think about the other attached law of indices, and that would be a to the 5 divided by a to the 7, and you would know that that would be equal to a to the 5 minus 7. So converting that into a log law, then log to the base a of 5 divided by 7 is equal to log to the base a of 5, take away log to the base a of 7. And think of an example where that might come up. Can we do what is log to the base 2 of 56 take away log to the base 2 of 7, if you were given that question, well, you would use this law here to say, well, okay, I need to do log to the base 2 of 56 divided by 7, which is log to the base 2 of 8. And remember, this is saying what power of 2 is 8, so the answer is 3. So we had, this was my rule of indices, and you can see very closely linked is my law of logs. I'll just try and make that a bit clearer. So that's 5 take away 7. Sorry for. So when I bring it out of the power, I'm still subtracting, and again they're dividing on this side. Very, very closely linked formulae to do with powers, just separated because obviously a log is technically an inverse of a power, finding an inverse power. So the rule is, if you're adding two separate logs, you can multiply them to make the values to make a single log. If you're subtracting two separate logs, you can divide the two separate values to make a single log, and that makes life an awful lot easier. And in many cases, log to the base 6 of 4 is an irrational number. Log to the base 6 of 9 is also not nice, but if you add the two together, you get something that's nice. And again here, that's an irrational number, that's an irrational number, but when you subtract the two irrational numbers, you get nicely to a lovely rational integer. So it's very, very useful, and is used an awful lot, so make sure you know it. Thank you.